We're all hearing about these incredible breakthroughs in AI, right? It feels like every single day there's something new and amazing. But what if I told you that behind all that innovation, there's a huge silent problem that's just growing? It's built right into the systems we're racing to create, and it's costing us a fortune. So, what's the price tag on this problem? How about this number? $500 billion. That's not a typo. A 2024 report from McKinsey estimates that's the annual cost right now. And you know what? If we don't get a grip on it, that number is expected to more than double by 2030. So what is this $500 billion secret? It's not the cost of servers or some new software license. No, it's more like an invisible drag on everything, a mortgage we're taking out on future innovation. And it has a name: technical debt. To really get why this is such a massive deal, we've got to break down what we're even talking about. So let's dive in. What exactly is this technical debt? You know, the easiest way to think about it is like financial debt. Let's say you need something fast, so you just throw it on a credit card. It's a quick fix, right? But you know you're going to have to pay it back later, and you're going to pay it back with interest. Well, in the world of AI, taking shortcuts in development, that's like swiping the credit card. The interest is all the bugs, the slowdowns, and the super expensive rework you're forced to do down the line. But here's the thing. The kind of debt we're seeing in today's AI is a totally different animal. In traditional software, debt was usually about some messy code that was a pain to maintain. But with agentic AI, the systems that can act on their own, the debt is way more complex. We're talking about unpredictable things the AI just learns on its own, or ethical drift, where a model's values slowly change over time, or even model decay, where its performance just quietly gets worse and worse. This isn't just messy anymore. It can be genuinely dangerous. And this debt isn't just one single thing. It actually shows up in a few different ways. You can think of them as the 4 key faces of the problem, the main areas where these shortcuts build up and threaten to bring the whole system crashing down. Let's take a look at each one. First up, we've got algorithm debt. This is what happens when teams take shortcuts. Maybe they stop training a model too early or use an outdated algorithm because it's easier. It creates this algorithmic brittleness. And we've seen what happens when this goes wrong in the real world. That big robo-taxi fleet failure in 2023, that was a classic case of algorithms that worked great in a clean simulation, but just fell apart in the messy, unpredictable real world. Just as important is data debt. I mean, an AI is only as good as the data you feed it, right? So if you use biased or just plain old data, you're going to have huge problems. They call this data drift because the real world keeps changing. And get this, without constantly retraining, a model's performance can drop by 2 to 4% every single month. And that brings us to the very foundation of the system: architectural debt. This is like building a skyscraper on a shaky foundation. It's about poor design choices that slowly cause architectural erosion. And that's not just a vague feeling, it's measurable. Without a deliberate effort to fix things, a system's core structure can get weaker by an average of 7% every year. And of course, all these different parts have to actually talk to each other, which leads us to integration debt. This is the headache that happens when your shiny new AI has to connect to older legacy systems. Things break. A lot, and it is a massive waste of time. One study actually found that engineers can spend nearly a quarter of their time, up to 23%, just trying to fix these broken connections. Okay, so the problem is huge, it's complex, it's got all these different faces. It's easy to feel like it's this unstoppable monster. But here's the good news. It's not. There are really clear strategic ways to get this debt under control. We just need a repayment plan. You know, the most important thing to get is that technical debt isn't some permanent failure. It's just a natural side effect of moving fast and innovating. The best companies out there don't try to avoid it completely. Instead, they measure it, they manage it, and they have a plan to strategically pay it down before that interest gets totally out of control. Getting good at this is a journey, and it's often mapped out with something called a maturity model, just like this one. Companies usually start at level 1, where they're just reacting and putting out fires. But they can evolve all the way to level 5, where they're actually using AI to predict and prevent debt before it even happens. It's all about that shift from being reactive to being proactive. So with all this debt piling up, where do you even start? Well, a lot of smart teams use a surprisingly simple but powerful tool: an impact versus effort matrix. You basically plot out every problem based on how hard it is to fix versus how much good fixing it will do. This helps everyone focus on the quick wins, those high-impact, low-effort fixes that give you momentum, while you strategically plan for the big, major projects. And once you know your priorities, you need real strategies to get it done. Some of the most effective teams just block off about 20% of their time every sprint just to work on reducing debt. For the really big, hairy problems, they might even create special tiger teams. The key is treating this cleanup not like a chore, but like a critical investment in the future of the product. Okay, so managing debt with sprints and matrices is great, but it's still a very human process. The truly cutting-edge solution, the thing that gets really exciting, involves a fascinating twist. What if we could use AI to solve its own debt problem? And that raises a really big question, right? When your system is constantly learning and changing and developing these unpredictable behaviors, how can a team of people possibly keep up with all the debt it's creating in real time? Well, the answer is actually kind of poetic. You don't try to keep up. You turn AI on itself. You build intelligent systems whose entire job is to watch, analyze, and even fix the debt in other AI systems. So what does that actually look like? Well, it starts with things like automated debt discovery, where AI tools can scan millions of lines of code to find hidden problems that a human would just never see. Then you've got intelligent refactoring, where AI assistants basically act like an expert programmer sitting next to you, suggesting improvements. And the ultimate goal? Self-healing systems. Systems that can detect a problem, figure out the cause, and fix it, all on their own, without a human ever lifting a finger. And believe it or not, this isn't science fiction. It's happening right now. For example, Google built a tool called DebtScan that uses AI to hunt for these issues. The result? It found 43% more potential problems than the best traditional tools they had. That is a huge leap forward. So we've looked at the problem, we've looked at the solutions. What's the big picture here? When you pull it all together, what's the one thing you should take away from all this? Really, it comes down to a fundamental balancing act. At the end of the day, this whole thing is a constant trade-off. Every company is in this relentless race to innovate faster than the competition, but speed always has a cost. The real grown-up challenge is balancing that need to move fast today with the need to build systems that are stable, reliable, and sustainable for tomorrow. It's about building for the long haul, not just for the next flashy demo. And that leaves us with one final, pretty important question to think about. Technical debt itself isn't evil. It's a tool. It can help fuel incredible innovation. But just like any kind of debt, if you take on too much, it can be absolutely crippling. So as we all race to build this amazing AI-powered future, we really have to ask ourselves, are we taking on way too much debt to pay for it?